Welcome everyone to Cloud on Air from the Google Cloud team. My name is Darren Strange and I work on our Google Cloud Platform Sales Strategy team. And I'm your host for the webinars that we've got for you today. Now the intention of these webinars is to give you a really good overview and introduction to Google Cloud Platform. So we're going to do one overview session that just helps you get the lay of the land, helps you, find your feet in this platform. And then we're going to drill down into more detailed sessions so you get a really good understanding of some of the key pillars of the Google Cloud. Now, it's very important that this is a live session. It's interactive, so we hope you'll enjoy that. One of the things we'd love you to do is to ask your questions down below. So if something strikes you, please do that. Enter your question here down below. And at the end of each session, you'll also find there's a feedback that comes up. It would help us a lot if you just give us some feedback. So if you can even just put a few words down to tell us what you like about this format, how we could make it better, we'd love to have that. So I'm going to kick off now with our first session to get into this. So we're going to be talking about an overview of the whole of Google Cloud Platform. Quite a tough job to do in a short session. So I'm very pleased that we've got a really good speaker to cover that with us. Mehran Alavi is a customer engineer. That means he is a technical lead on our enterprise customer projects. He's got a lot of experience, sees a lot in his travels, so I'm very pleased to introduce him and have him take us through this introduction to Cloud Platform.
Hi, my name is Mehran Alavi. I'm one of the customer engineers here in Google Cloud Platform. I'm going to today run you through an introduction to Google Cloud Platform. So to begin with, let's set up the agenda. I'm really going to run you through some of the introductory steps of the infrastructure, the database services, the machine learning and analytics, and then we're going to take it from there. This session is going to be at high level, just touching on different products and what's available at your hand. Let's start with a little bit of background of Google Cloud. Google formed about 18 years ago, and our mission statement is to organize world's information and make it universally accessible and, of course, useful. We started indexing internet since about 2000, 2002, and at that time, we had to go through about 1 billion web pages. And it turns out indexing billion pages is a really difficult task, and we faced many different problems, and we had to fix for all of those problems, find a solution for all of those problems. But let's talk about today. Today, you type an average about 3 words in your Google search bar, and then Google goes and starts searching for different results, and it goes through about 35 trillion web pages and return the results to you within milliseconds. This is an amazing performance. This is very fast returning results to you. But this doesn't just happen by magic. Behind the search engine, behind this clean interface of Google search, there's a big infrastructure and footprints across the globe in different locations. And this infrastructure doesn't just support Google search engine. There are other products within our portfolio. There are other businesses within our portfolio. These are businesses that all of them already hit more than 1 billion users. Some of those logos are familiar to you, like Android. In fact, Android has about 2 billion users on the platform, 2 billion active users on the platform. On YouTube, about 1 billion hours of YouTube video is being streamed down by the users every day. And we have to have scale for all of these businesses and products to be successful. Now that we have 7 businesses that each of them have about 1 billion users and active users on top of them, we are ready to take it to the next step. We are ready to go for Google Cloud Platform and launch that as a business. So we already have the infrastructure, but now we also need to make sure about the technology that we have on top of it. Throughout the years, we need to solve for different challenges that we came up with. Some of the names and logos you see on the screen might be familiar to you. These are all the internal products that we had to create to solve for those business challenges. But we also, after solving those challenges, we wrote a white paper and took it back to the community. We open sourced all of those products. And in fact, Google Cloud Platform is based on all of these open source technologies. So each product that we used or we are using in Google today, we also make that available to you to use it as Google Cloud customers. We have a big infrastructure. In most popular locations around the globe, there is a data center, there is a region available for running Google Cloud Platform. In fact, in the few months ago, we launched few new data centers like Singapore and Sydney, but for the rest of the year, we have a plan to launch other data centers like Mumbai, Finland, Netherlands, South America, Montreal, LA. These are all the new data centers that are going to launch. New regions for Google Cloud are going to launch in the rest of 2017 and also for the next year. And all of these infrastructure are connected together based on the dark fibers that is owned and operated by Google. This is private network that Google is running, and it is connecting all of these locations and POP services and data centers together. So that means that as a Google Cloud customer, once you start running your business on this platform, you're technically going to use the same infrastructure that Google is using for running all of those different businesses that I just talked about, like YouTube and Google Search and Android and stuff like that. That means that regardless of the size of your business, whether you're a small startup or you're operating at the Google size, you can also use the same infrastructure and facilities and same products. In the platform, there are many different categories of services, like compute, big data, analytics, machine learning, all of those, just a click away. You can just click on them and create those resources. But let's begin with computing. Computing is really going to be considered as where you're doing things. And it comes down to maybe three main categories. You want to use virtual machines, you want to use containers, or you want to use serverless architecture. But let's dig into each of them one at a time. When we're talking about compute engine or virtual machines, this is really something that's also provided by other services. But in other services, when you want to go for that, probably you're going to end up choosing between t-shirt sizes, some set virtual machine sizes like 8 virtual CPUs or 16 virtual CPUs with some set amount of memory attached to that. But in the Google Cloud Platform, if your application, if your business demands to have only 10 virtual CPUs with, let's say, 9 gig of memory attached to that, you can have that. That's the resource, that's the right resource you have to use. And then if you want to maybe create a server, run your application on top of it, and save it to be reused at a later point, you can do that. And in fact, if you don't want to waste the time on configuring your own virtual machine and go to the market and find a virtual machine that's already created for your own specific use case, you can also use that with the help of Cloud Launcher. But the point is that whatever solution you use, your service is going to come online within tens of seconds. And then Container Engine. Container Engine is basically managed Kubernetes. And Kubernetes is really the platform that we are using in Google to run microservices. Internally, we call it Borg. We published a paper named Borg, but really in the market, it is called Kubernetes, and it's an open source tool. You can configure your Docker images based on pods and configure them in a microservices approach or batch jobs approach, or maybe you can create scheduled jobs. But the point is that Kubernetes as a platform automatically is going to take care of the scalability of your environments. If you want to have an API layer with some, let's say, 4 Docker images within that, Kubernetes as a platform will make sure that you only have 4 of those. If it loses any nodes, it's going to create another one and give you the same level of resources available. I just talked about the container engine and how it works. It automatically does the monitoring, logging, DNS, service discovery. All of that is right out of the box. I also mentioned that Kubernetes is an open source service. It means that you can take it to your premise and start running container engine within your infrastructure or other providers' infrastructure. But the point is that when you take it there, although Kubernetes provides you scalability out of the box for your containers, but it doesn't provide you scalability for the nodes that are running Kubernetes. And that's why Kubernetes in Google Cloud is a managed service. That's why I'm saying it's a managed service, because it's also taking care of the scalability of the underlying infrastructure as well. If you want to do it yourself, It is very difficult. You need to take care of monitoring, logging in DNS, and all of those stuff I just mentioned. But if you bring it to Google Cloud, it's just one click. Create a container cluster for me. You just set the criteria for that, amount of resources you need, and job done. The other approach to run containers, or think about a serverless architecture, is to go for App Engine flexible environments. This is a Docker-based environment, which also gives you the capability to bring your own Docker images, put it on the platform, and just run it in an auto-scaling manner. It gives you an endpoint. You're just interacting with that endpoint. Super easy. There's also container registry available within the platform for Kubernetes, for App Engine Flexible, which I just mentioned, or even if you want to bring your own Docker containers, you can put all of them in the Docker registry, and you can tie some security measures around that, so only your Google Cloud Platform resources have access to that environment. As well as that, Container Builder is also another product within the portfolio, which if you are into having a CI/CD approach, you can definitely benefit from the Container Builder approach instead of having third-party applications with just dropping in and out of your platform and using them. I mentioned about App Engine, about the flexible environments. I also mentioned that it is based on Docker as an infrastructure, but Docker is not the only choice you have within that. There are other programming languages that you can see on this slide, and it has capability with all of them. But then there is an App Engine standard environment as well. App Engine standard is a little bit tighter environment. It's not based on Docker. There's a caveat to that, but in return, you have super fast scalability. There's a limitation to number of languages you can use, but in return, again, you get that millisecond scalability, not only scaling up, but also scaling down, and make sure that you're not wasting any money on the traffic that you're not receiving. And ultimately, Cloud Function that I just mentioned. These days, we want to think about that one specific super line of code that does some actual thing for us, instead of thinking about building an application, running an operating system, or even running it in a Docker container. You have a code that, for example, is watching, let's say, a bucket in your storage area, which I'm going to get into that a little bit later. And based on an event that happens, let's say an image gets uploaded, you want to trigger an email, or you want to trigger a resize process. And all of that can happen within the Cloud Function service as a serverless architecture. The other thing that we need to get into is networking. This is actually where things are connecting to each other, and all the things that you were doing before, now you want to connect them together as well. Let's start with connectivity between resources. Within the platform, there's a service named Cloud Virtual Network, and the Cloud Virtual Network gives you an isolated area to have connectivity between the resources within your projects. Let's say compute engines that you created or Kubernetes cluster that you created, all of those would go through one virtualized environment and have private connectivity together. And the other side of the connection piece is that you want to have Cloud Interconnect. Cloud Interconnect gives you a capability of connecting your facilities to Google Cloud Platform. If you are running a dedicated environment on-premise, you can now have that connectivity with the Google Cloud Platform as well. Or maybe you're running it on a different location. Having that direct peering between your location and Google Cloud. And then VPN, it's really connecting machines to each other in a secure manner. And the security piece of it is that it's going to support IPsec for you. And firewall, of course, firewall should be there. It's just a given thing. You can create rules, you can create tags, and based on those, define what type of traffic can go out of your platform, what type of traffic can come into your platform. And this is where you get those things set or configure or define them in the firewalls. Now, I want to create a solution that Google doesn't support or doesn't provide. Okay, that's fine. You can always roll back to Compute Engine and create your own virtual machines and set whatever you like on top of it and start operating it. There's no limitation in that. Or you can have a better approach. I talked about Cloud Launcher earlier on. You can use industry-built predefined solutions like Barracuda, Brocade, Cloudflare. Within seconds, you can spin up one of those resources and start applying security through those products. Now, within the networking, let's also discuss about the availability. CDN is one of the key things as well. You want to make sure that you bring your content as close as possible to the end user to create a better experience for those. Same type of experience that YouTube, for example, is delivering to the customers. You just need to enable CDN on your load balancers, and automatically the static content that you have would get cached in one of Google points of presence closest to the end user. And DNS is one of those interesting services. Actually, DNS is not that interesting, but the interesting part is that you're going to receive 100% SLA based on the DNS service. The same DNS that Google is using internally as well and externally, you get to use the same thing. And the load balancers. You want to make sure that you're going to distribute your traffic across different regions, between different resources. But the way that you're going to do that, I don't believe it should be through letting your provider, letting us know, so we can pre-warm those load balancers, because you're going to have an event, you're going to have a massive spike in your platform. You should be able to have that scalability as you wish. And you're going to have that based on the type of traffic you're receiving. So you don't need to let us know that you're going to experience more traffic. It just happens automatically. And the good thing about it is that these are, you don't need to create these load balancers based on different regions. You just create one load balancer and it distributes traffic based on that dark fiber private network that I just explained. It uses the same networking for the load balancers as well. Let's talk about storage as well. Of course, you want to keep your files, keep everything you're doing. That's going to happen in storage, obviously. We can tackle it in kind of different approaches. We can think about the files or objects you have. We can think about the databases you're going to have, or we can also think about it from a big data perspective. From a file storage, there are a variety of different approaches. Let's say the nearline and cold line, think about them as archiving methods. And then multi-regional and regional are your day-to-day operational. I'm just going to get into a little bit more detail about each of them. But the point is that you either have public content that you want to make it available, or you already processed some data and now you want to store it, or you have long-term storage, which I just called it archiving. But kind of a cheat sheet to think about all of these is to think about your public data. The public data probably needs to get to your end customers as fast as possible, so you want to make it in a multi-regional approach available to your end client. Or maybe you've already done some batch processing based on big data or other data analytical tools, and you just want to store that because you have more frequent requests and access to that. You're just going to store that on a regional basis. But then the other two, nearline and cold line, depending on the frequency of your accessing your data, let's say you have some archival requirements, maybe once a year, once a month, you want to access those files. You're going to make a decision based on that, how you're going to have access, which one of those products you're going to use. But the real point here is that you're going to have access to your content within milliseconds. You just don't need to send a request to us to say, release my archive, and you're receiving that within 4 hours, 8 hours. That's not the case. Immediately you have access to all of the content you stored on cold line or nearline platforms. Let's touch on databases as well. There are a variety of databases available. Let's start with Cloud SQL. This is basically MySQL, and also alternative version of that, PostgreSQL. Relational databases, but the only difference is that it is managed by Google. You have managed backup. Automatically, it can track the minor version upgrades, and also it's going to take care of the scalability of the platform as well. But then on the other hand, you have a monstrous type of database, which is Cloud Spanner. It can handle the structured data. It can have high availability, strong consistency, global distribution. You might think that that's not possible. Yes, true. The guy who came up with the idea saying that this is not possible and there's a restriction for achieving all of those is actually working for Google, and he contributed to developing this Cloud Spanner platform. And the reason that we can have all of those at the same time is relying on those private networking that we have between different data centers. The dark fibers that we have and own and operate gives us the capability to kind of address for high availability within the environment. And also the atomic clocks that we are running in our data centers gives us a chance to make sure that we can keep track of the consistency of the data and the exact time that the data got submitted to the database as well. And then NoSQL databases. Cloud Data Store is one of those products that can give you a massively scalable platform for storing your NoSQL workloads. It can work with Compute Engine. It can also work with Kubernetes as well, natively right out of the box. And then Cloud Bigtable. Cloud Bigtable has super low latency. It is based on HBase API. So if you're internally using HBase today, it is very smooth transition to come to Bigtable and start using Bigtable. And now let's also touch on big data and how we should think about those. Within the Google Cloud Platform, there's another product named BigQuery. You can think about it as data warehousing. But the only difference is that you don't think about capacity planning. You don't think about the amount of resources is required to process your data. It's just there. Google is not using it, so you can use that. You just create your SQL job, put it there, you point it to the data source that you have, and run your query. How long it's going to take to complete that query depends on how many resources we need to spin up behind the scenes, which you don't need to know about them. We're going to get the job done as fast as possible. And that's BigQuery. It is very easy to use, and it requires no skill to use that, as long as you know SQL as the basic. Other services such as PubSub. Of course, you want to receive all of the messages and bring them to Google Cloud Platform, and PubSub is going to give you that capability. This is a messaging bus spread across all of the data centers, spread across different locations, and it can handle millions of requests per second. So let's think about an IoT solutions, and all of those devices from fridges, TVs, and all of the smart devices are sending messages to the Google Cloud Platform. PubSub is going to be the savior, and it can receive all of those traffic. And then with data flow, you can do batch processing or stream those data to different data sources or different analytical tools that you're using based on open source Apache Beam, and benefit from data flow and the functionality it provides. And also, if you're already running a Hadoop or Spark workload in-house or somewhere else, and you want to bring your workload to Google, Dataproc can help you. It has auto-scaling out of the box, and also you can make a lot of cost saving, because again, you don't need to plan for the amount of capacity you need. Dataproc does auto-scaling automatically. So all of these products that I just talked about, they can get glued together based on PubSub and cloud storage. On the right-hand side, you see all the analytical tools and also compute resources that I just talked about. On the left-hand side, you see mostly the data stores and databases. And at the bottom, we have the machine learning stuff, which I'm going to just touch on that as well. But before going through that, let's again discuss those solutions that Google is not providing you. Again, creating a virtual machine is a solution. You can put whatever type of application you want to operate and run on top of virtual machines. And then in Cloud Launcher, again, you have capability of running services such as Redis, Mongo, CouchDB. All of those are available and predefined and kind of pre-cooked there for you, and you can start using them. So all of these products that we have in hand, we also need to find a way to operate them. We need to find a way to deploy them, manage them, making sure that they are running, getting reporting on them to see how we are operating our environments. One of the ways that we can do that is using Stackdriver logging functionality within Google Cloud Platform. The super cool feature about that is that it not only supports Google Cloud Platform, but if you have a multi-cloud strategy, you don't need to look anywhere else. Stackdriver is going to help you. You can also monitor your AWS platform. You can also monitor your on-premise resources with Stackdriver logging. And with stack driver monitoring as well, you can have the same capability between Google Cloud Platform, GCP, and also AWS. And alerts are also going to get generated based on logs, uptime, and other type of alerts that you can set as well. And Cloud IAM is a way that you can secure your resources as well. It can be product to product, machine to machine, or maybe users or groups getting correlated together. All of that can be defined within Google IAM. And when it comes to configuring those resources, we have Google Cloud as a tool. There is a G Cloud. There is GSUtil as command line tools. And you can interact with all of the product that I just mentioned in a very easy way. But if you want to be super geeky, you can start writing the API, RESTful API commands and get access to the product, or actually use one of the SDKs that are already defined in many different languages to make the job a little bit easier. And Deployment Manager is another option available for you as well. Instead of every time start thinking about creating resources, creating networking, defining those securities, and putting everything together exactly how you want, you can actually do that once and commit it to Deployment Manager. And if you want to repeat the same thing again, you just use the Deployment Manager to deploy the same thing. I kept the most interesting part for last, machine learning. This is where you want to use the models. You want to think about creating models maybe, and also extending the models to Google Cloud Platform. Google already created and worked on predefined or pre-trained API sets for machine learning. Like Vision API is one of them. It can, out of the box, it can give you a capability to do face detection, label detection, or let's say character recognition. You want to take a photo of a sign, and you see what exactly is written in a photo in a form of text. You can do that through Vision API or Natural Language API. It understands everything that's mentioned on this slide, but one of the cool ways that one of our customers is using that is to receive comments and feedback from their customers, and also get the sentiment extracted from all of those, and do the analytics to realize how happy the customers are within their by using the service. And then Speech API. Automatically, you can recognize the speech. You can customer service. Think about it. Think about something like that. Customers are calling. You want to capture what they are, what type of conversations they are having, and then just submit that to the databases you have. It can do that based on Speech API, and it supports 80 languages. And then Translation API. It just says it on the name. You can do translation based on that. Think about wiki pages across different offices, talking different languages. And then Video Intelligence API. You can detect shots within a video. I have a video with many different shots, but I just want to automatically jump onto the shots that has a beach, for example. Within Google, we solved for machine learning problems based on creating a product. Again, machine learning is one of those technologies that we couldn't find something available outside, so we had to innovate and develop ourselves. And TensorFlow was the machine learning library that we had to build internally. But we also took the same kind of library to the public and made it externally available as well, which is an open source platform today. You can run it on your own laptop. You can run it on another cloud provider. You can run it in-house. It supports CPU, it supports GPU, and you can use it. But the point is, once you start using that, you want to do prediction based on the models that you already created, or based on the models you already created based on TensorFlow. You want to take it inside your premise and start doing predictions, vice versa. And Google Machine Learning or Cloud Machine Learning is going to help you to do all of those predictions and training for your model as well, based on a managed TensorFlow. The platform is managed because it is automatically does self-tuning. It is portable. It is scalable. It does take care of everything behind the scenes, so you're just using it. So I discussed about many stuffs. There are a lot more products to discuss. I tried to touch on them as much as possible. But the purpose of this session was to give you an overview of all of the services available. We can always dig into other products at a later point. Thank you for listening.
Well, thanks very much for that, Maran. Quite a lot to cover there, didn't you? You had quite a lot of ground to cover in one session.
Yeah, I know. In 30 minutes, it was a really difficult task to do.
Yeah, thanks for that. Well, we've got some great questions coming in, and I hope you're enjoying the interactive nature of this format. Again, make sure you give us your feedback and continue to ask us questions. We're going to try and answer as many as we can, and any we don't get to, we'll follow up later and make sure they're covered online. So let's jump in.
Sure.
So first one here. So I have an app with Angular 4 front end and a Rails back end. The DB is based on MySQL. How do I connect such an app together on Google Cloud? Maybe I should use a Docker container. So quite a lot of architecture there in one question.
True. I think that's a great question. Another way that I would like to rephrase that question is that what would be the best way to move my internal application to cloud, or the application that I'm running on my computer into a cloud platform? I think to begin answering the question, it's really worth to understand that whether you are running on Docker containers today or not. If you're not running on Docker containers, probably there are other avenues that you want to explore. But if you are running on Docker containers, I should say Docker is the best way going forward, like running on Kubernetes, managed Kubernetes platform. Right. Really makes sense because it removes the hassle of the management of the platform. And then on the point of the database, there are managed databases on the platform, like MySQL has a managed platform. It takes care of the replication, it takes care of the management of the platform. You just need to import your database into the environment, into Google Cloud. But then...
So I guess you could always fall back on moving the VM and really just recreating a whole infrastructure in the cloud with VMs. But I guess what you're saying is you've got different levels of abstraction, and you could probably get rid of some of the management work that you had when you were running that yourself. I guess either on the database platform, you're saying, or ultimately in containers as well. So.
Absolutely. Absolutely. You can run everything on virtual machines. You're just making it more difficult for yourself. Right. If there are better options already available on Google Cloud Platform, and that's really what we're trying to deliver to our customers, you're better off using those services because you're going to be more productive, focusing on your main application, focusing on the code, focusing on your business instead of focusing on maintaining a platform. Right. For the Angular and Rail, there are options. As I mentioned, VMs is one option, but there are other options available as well, like App Engine. It supports Ruby, it supports Node.js as well. So maybe it's worth exploring those options as well. But in general, when we want to move an application into a cloud platform, it's worth getting into the dependencies that you already have and prioritize which application would be nominated to move into cloud first.
Cool. And I guess we kind of take a serverless approach to things if we can. So, but you've always got those other options if you want to manage it. Correct. Let's crack on. Anyway, next question then. Can I run Spark on Google Cloud?
That's a great question. Yes, you can. You can always create virtual machines and run your application on top of it. Yeah. But that's not the best option always. There are other alternatives within Google Cloud Platform as well, like Dataproc is one of them.
Why would you use Dataproc? Why would you not just run it yourself?
That's a really good question. Dataproc delivers Spark and Hadoop. And if you want to focus on doing big data instead of taking care of the scalability, sharding the data, distributing the data between different nodes, you better look into a managed service that delivers that out of the box. And Dataproc basically delivers that. It removes the cost of management. It also removes the cost of creating additional nodes because it does that out of the box, whether you want to scale up or scale down.
It's spinning them up and taking them down.
Absolutely.
For you. So I guess you're saving money as well because you're actually not running those clusters all the time. So you're only running them when you need them.
Correct. Have you tried to configure Hadoop or Spark out of the box?
Yeah, I try not to think about it.
I guess not. That takes time. But with Dataproc platform, you just define how many nodes you want, what is the version you want, and create. Boom, it's there. You're ready to go into production. Just put your data on it and start using it.
And there's nothing wrong with if you're happy with Hadoop. There's no reason why you need to change that. But using Dataproc just takes a lot of that pain out of the equation. So you're getting to all the benefits of the cloud and less of that management overhead.
Yeah, absolutely.
Fantastic. All right, great. Let's move on to this topic of security and I guess compliance in general. Let's just talk about that. So if I'm going to move a cloud-based solution to a cloud-based solution, how do I ensure that the data is encrypted? Is it safe? General concerns about moving to the cloud's common thought. So what are your thoughts on that?
At Google, in general, we take security very serious. And in Google Cloud, it is exactly the same. And in fact, there are only a handful of people that have access to our data centers. So when it comes to security and...
Have you been into a data center?
No, I haven't. I was wondering whether I'm going to get a tour of data center or not, but they said, these are the pictures, these are the slides.
Actually,
that's the best you can get.
Have you seen there's a Google Cardboard thing you can actually go and do the virtual tour. So if you're really interested to see a data center, you can do it that way, but you won't get in. It's a very, very secure facility.
Yeah. But in general, when it comes to Google Cloud security, everything within Google Cloud is encrypted at transit and also at rest, in transit and at rest.
Right.
So you don't need to think about applying encryption into your platform, into your data. But if you want to do the encryption with your own keys, you can definitely do that. We can also manage your keys as well to make life a little bit easier. And I think that sums it up. But I saw another question on the same, kind of around the same topic as well, that was very focused on the availability of the data, or maybe limiting the availability of data to one particular region.
Yeah, if you were in the EU and you didn't want the data to, say, go to the US, and you didn't want your queries running there, say you're using BigQuery or one of those tools, is that possible? Can you kind of keep things within the region?
Absolutely. I mentioned a little bit earlier in the presentation that you have a choice of regions and zones, and that also gives you a capability of limiting the location of data to those particular locations and regions. Like if you have a concern of making sure that you have your data available only in Europe, you can choose those regions within Europe and just focus on those.
And there's loads of more on the compliance side of things as well. If you want to check out the papers, much more detailed answers. Obviously, a crucial topic, so hard to cover in a minute, but go and check out those resources too. So let's just talk a little bit about different ways to get large amounts of data into GCP. So if customers have data on premises, what's some of the ways that people get them up there?
I would say option one, explore how you can upload them to cloud. But there's always an argument that I have lots of data, and if I want to do that, it's going to take so many years to upload all the data to Google Cloud. But recently we deployed a new storage appliance that we can send it to you, and you can put your data on top of that and then send the appliance back to us, and we can import your data into Google Cloud. So the time that it takes is to send you the device, copy the files, receive the device back, and then copy them into your Google Cloud platform.
But people do underestimate how much we can absorb as well. We're used to taking large amounts of data, so it's really the link at your end. We can consume. We see customers uploading hundreds of terabytes a week. So, it is possible. Don't rule out just uploading, I guess, is the point as well. Fantastic. So let's just treat this last one here around latency. So one of the questioners here saying, "Oh, well, I'm in Israel. It looks like Frankfurt might be the closest DC to me. How do I cope with that? What's the right place to put things for that aspect?"
I think that's a valid question. I'm going to keep it short and sweet because I think we're running out of time. But always explore the closest data center to your location, or closest region to your location. If you feel like, and it also depends on what is it that you want to serve to your customers. Is it an internal application that you're putting on cloud, or do you have a global audience that you want to target? What is the scenario?
And I guess you can ping test as well to figure these things out.
Absolutely.
Right? I think we're kind of out of time, so I think we're going to have to wrap things up. But we could talk for ages. But thanks so much for those questions. Any we didn't get to, we'll definitely go online and try and answer them as best we can. So that's it for now. Stay with us for Cloud on Air.